Hi everyone, welcome to today's episode of the Great Backend Engineering Podcast. And today we are going to be talking about microservices for backend engineers. And I have a very important guest who is here to share his knowledge around microservices. So let's introduce Vikas. Vikas, please introduce yourself.
Hey, thank you so much for having me on this podcast. And I've been following your podcast really well. And I've watched a couple of episodes of your podcast, and they are really insightful. My name is Vikas. I'm from India, and I'm basically working as a backend engineer. I have 10 plus years of experience into backend. And initial 6 7 years of my career, I have worked as a full stack engineer, where I've used technologies like JavaScript, TypeScript, React, Angular to build the front end. And I have mostly used Java as the backend technology to build the backend services. Since
Hmm.
3 4 years, I'm more into backend because I've realized my more of my interest lies into backend. So that's why I have started, uh, mostly taken the role of a backend engineer. And
Mhm.
with that, I also, since 2 years, I'm also writing content online. Twitter and LinkedIn, mostly I prefer those two platforms to write my content, and I'm learning and sharing what I'm learning along the way in my journey of backend. And I'm overwhelmed with the kind of response I'm getting on my content. And yeah, and so basically uh, by day I'm a backend engineer, and by night I turn into a writer. And that's what I'm doing, and I'm really enjoying my journey so far.
Awesome. Thank you very much for uh, agreeing to join the podcast today. So, the Great Backend Engineering Podcast is a podcast where we break down complex backend engineering topics and we try to make backend engineers to learn and advance in their careers. Okay, so Vikas is a senior Java engineer and he has been sharing his journey on Twitter and LinkedIn for over 2 years now, and that's how we got connected. So I used to follow his content on Twitter, and they are really really insightful. So you should check it out. Okay, so in today we have lots of questions to ask around microservices, and I'm going to make sure that Vikas gives us his insight and knowledge into these questions. Okay, so we are going to first start by asking him what is microservice, right? This is a question that I really want to, newbies out there to learn because when starting backend engineering, the first thing they want to think about is maybe after building cron applications, the first thing they want to think about is microservices, right? And it can really be fun, but sometimes you need to actually know the foundations of things before you get started in them. And today I want Vikas to break down what microservice is and also talking about the differences between microservice and monolithic applications so that we have a clear foundation for us to start our discussion.
Correct, correct. Yeah. So it's a very important question to understand, like what is a microservice basically, right? So from a very beginner's perspective, if I try to explain what is microservice, then consider that you're having a e-commerce application. Okay, think about Amazon, for example. Imagine that Amazon is a monolith application. Now, monolith application means it is a single deployable unit. It's a single project where every kind of logic is written right inside that, say it authentication, or the APIs which is fetching the products, or APIs responsible for making the payment. So everything is bundled into one single unit, that you can
Mm-hmm.
say it as a monolith application, right? Now,
Yeah.
what is a microservice architecture? So let's say Amazon is a very I'm just taking an example, okay? Don't consider that I'm talking about Amazon. It's just an example, right? Apart from
Of
Amazon,
course.
you can consider any other e-commerce platform as well, right? So let's say your e-commerce platform has grown into a very big application, and managing it is a bit of a bottleneck, and from performance point of view also there are some sort of challenges you are facing. So what
Mm-hmm.
eventually people do, they break this application into mini services, right? So these mini services, they call it as a microservice, right? So
Yeah.
for example, if I take the same example of e-commerce, then it can be broken into multiple microservices, which is
Yes.
one, you can have it user service, which is responsible for registering the user and managing the overall user profile, right?
Mm-hmm.
Uh, Another could be the cart service, which you can add any items to cart, and the service which is responsible for managing the entire cart of your application. Then you can
Yes.
have payment service, which is responsible for doing the payment and integration with other payment gateways, right? Similarly, you can
Mm-hmm.
have a product service to list the product. You can go and search products, right? You can also have some recommendation-based service, which is responsible for showing you any similar types of products which you may be interested in, right? So likewise, you can go and break those services into small services, which you call microservices. And
Yes.
these services are independent in nature. You can deploy these services independently. They follow separate release cycle, and there is a separate set of team they work into this services. And that's why you can have multiple teams. They can work in parallel in this microservices. They can the development also becomes very easy because separate team, they are working on separate microservices, and they can do anything
Yeah.
in parallel. They won't be touching each other's code, right? As
Mm.
compared to monolith, where everything is there inside one piece of code. So
Yes.
you may be blocked by some unwanted code introduced by some developer who may not be working with you, right? So all those kinds of issues can be tackled using this microservice architecture. And each
Mm-hmm.
service is a single deployable unit, follows the separate release cycle. It may also have its own tech stack, right? You can use
Mm.
multi-stack environment where you can use Node, Java, Python at the same time, right? That is also one of the
Yes.
advantage you get in microservice instead of monolith, where you have to be very picky in terms of using what programming language you are using, right? So these are like all the benefits of microservices. And the benefits, other
Mm-hmm.
benefits of microservices, is that you can scale selectively. Let's say if you're uh, you know uh, expecting some high load on your application on some flash sale day, right? Or there are some famous kinds of sale like Black Friday sale day. Okay, so you can selectively scale your product service, right? Because you may be expecting a lot of load on that particular service, right? And
Mm-hmm.
you can selectively scale it. You can actually save some money there, okay, as compared to monolith, where you have to scale your entire application, right? And the other parts of your application may not be needed to scale, but you're still scaling it because your application is bundled into a single unit, right?
Together.
So there are all these types of benefits you get when you use microservice over a monolith application.
Awesome. So this is a complete breakdown of microservices, and I really love it. So I'm going to try to articulate some of the characteristics that you've mentioned. All right. So the first one here, you said we have the coupled components. Each services is independent, meaning they can be developed, deployed, and scaled separately. That is awesome. And then another one, you mentioned something like single responsibility. Each service is focused on doing one thing very well, right? For example, you said in e-commerce, you might have a separate service for ordering, order processing, payment handling, and product inventory. And we all know that these are independent services, and they do that job of ordering processes and payment handling very well. Okay, so next you actually mentioned technology agnostic, which simply means that each service can be developed based on any programming languages that you choose to use. For example, if you want to introduce like an AI into your system, you might notice that okay, Python can be very good with this, or Golang can be very good with this, and then you just decide to use that language to build your system, which is awesome, right? And then you also mentioned resilient and fault isolation, right? Because since each service is isolated, if one service actually fails, the rest of the system continues to work. Unlike monolith applications where each services or features is bundled together, and if something failed, all the system actually shuts down for maintenance. So this is awesome, and thank you very much for explaining to us the different, characteristics of microservices and all of that. Okay, so I'm going to move on to the next question. Remember that we have a lot of questions to ask you today. And the second one is coming from a place where I like to know about why I should actually use a thing rather than just jumping into using it, because I don't like the idea of complexity before paying users. So what that means is that I like to start from somewhere and then progress as I move ahead. So I want to know, why should we actually need or use microservice? Monolithic application works. We can deploy them, of course. We can use that to build our services. It works. And we can actually modernize it and use modular monoliths. So why do we actually need microservice?
Yeah, very important question actually. You know, based on my initial introduction to microservices, we may feel that everything is good on the microservice side, but every architecture comes with some sort of challenges and some sorts of problems. Every architecture is optimized for some type of problems, right? And it's best suited for those types of problems, right? And same goes with microservice architecture, right? It's very important to understand when do you need actually microservice, right? So
Mm-hmm.
take a step back, okay, and do some retrospection whether you need it or not, right? That is one of the important questions to ask. You mentioned it very well that you can start small, and over the period of time, once you gain some user, then slowly when you start pushing more features, right, then you want to grow into bigger things, right?
Mm-hmm.
And that is where this microservice architecture can be beneficial. Let's say you are having a monolith application, okay, which is right now small in nature, and it is
Mm-hmm.
having some limited users, okay, and you are right now in a growing phase, okay,
Mm-hmm.
then this is not the perfect time to go and switch to microservice, right? It's very important to understand that microservice architecture may not be your first choice, right? If you're
Mm.
not sure what you're doing, then never start with microservice architecture, right?
Awesome.
Always start with a monolith application, okay, a monolith architecture. And over the period of time, right, if you feel that you need a requirement to make your service into microservice architecture, that could be your time to go with this type of architecture. Now, what could be those questions which you may be asking? First of all, whether your
Mm-hmm.
application needs scaling or not, right? Whether you are
Yeah.
expecting your users to be growing in the future, and what is the number of users using your application, how many concurrent users are using your application, right? That is also one of the questions to ask, right? Whether your application is having a various type of loads, is it experiencing various types of loads, right? That is also one
Mm-hmm.
of the main question to ask. And whether scaling your monolith application, right, is a challenge to you. If your application is very small and doing some particular stuff, it can be some basic SaaS application, right? And it's not that big in nature, then scaling your application may not be that much of challenge. And with this only, right, when you have a scaling requirement, you may not go and withdraw your application into Microsoft, right? Let's say your application is
Mm-hmm.
growing day by day, you are adding more and more features, more and more complexities are being added to your application, right? Your application is also growing in terms of user base, right? So that
Mm-hmm.
may be a time where you need to rethink about your architecture, and maybe going towards microservice architecture may solve your problem, right? Because
Yes.
initially, if you just simply start with microservice architecture, then microservice architecture also comes with some level of infrastructure cost which you may not need to pay for, right?
Mm-hmm.
Until and unless you have the need for it, right? So microservice architecture is good for when you need some selective scaling into your application, right? When, let's say, you
Awesome.
only want to scale your product service, right? You only want to scale your product service to some level and keep the rest of the services at the same numbers, then going with
Mm-hmm.
microservice architecture could be beneficial for you. right? Instead of monolith, right? Where in monolith you
Mm.
need to scale entire application at the same time, right?
Right.
And it may be a waste of resource and money because cloud hosting is very costly nowadays,
Yes.
right? So one is that selective scaling you need, then you can go for that. Another thing is that whether you want to leverage multiple technology stack into your application structure, you may need to, you can also go with that. And your
Mm.
application is growing more into, more in terms of complexity, right? In terms of architecture complexity, you have lots of integrations, you know, and your application is
Yes.
growing day by day, then that could be one of the other checkpoints where you might need to go for microservice, and microservice can be a beneficial in that case, right? In most of the cases, you will have, multiple factors, multiple of these answers needs to be true before you go to microservice, right?
Awesome. So this is great that is actually coming from you that have over 10 years of experience building these things, right? I see some people when they start building out applications, they want to include all the complexities that they can in that application. But I keep telling them over time that that's not actually the best way to go. Okay. And that's why I actually coined that term of no complexity before paying customers. The thing
Correct.
is, microservices is good, but it is a progressive thing, right?
Progressive
You
thing, correct, correct.
build out your system in the minimal possible way that you can. And then as you progress, you add complexity. That is what I see as, what could happen to microservices, how microservices could be introduced into your system pipelines, right? So build out a minimal version of your product or your system, and as you progress, the number of traffic that you get, the number of users that you have, all these different indications is going to show you if you need a microservice or not. And then kind of start introducing microservice into your system. Thank you very much for sharing that. And I believe people are going to learn a lot from you, not introducing complexity into their system at first start. Okay, so I have another question, and this one is supposed to be practical, but of course, we are going to talk through it. So, how do we transition from a monolithic application to a microservice? Now, remember that you said that microservices should come later in the product's life cycle. Now that we've developed a monolith application and we've had a reason to transition into microservices, all right, we have the users, we have the complexity, we have the scalability problems and stuff. How do we introduce microservice into our monolith application?
Right. So, let's say you are already having a monolith application, right? And
Mm-hmm.
now you want to go to a microservice architecture, right? Now, the first thing which will be, coming right on your way is you need to identify the different modules of your application, right? Different
Mm-hmm.
business, areas, right? Business functions you can consider, right? You need to
Mm-hmm.
identify them, and based on that you need to break down your application. Let's for example, if we take example of e-commerce application, then users can be one service which is responsible
Mm-hmm.
for registering the user and adding the user in your application and managing the user, overall user, right?
Mm-hmm.
Another service could be like product service, which will be responsible for adding some products, searching some product, right? uh, those kinds of stuff, right? There can be a payment service as well, right? So whatever code you have in your monolith application responsible for doing the payments, you move them into the payment service, right? This
Yes.
is how you need to identify all these different modules of your application, and
Mm-hmm.
then slowly you have to like create them as a separate service, right? And need to make sure that not single service should not be tightly coupled with the other service,
Mm-hmm.
right? So that part single service should be independent in its own way, because when you are writing your code in monolith application, you may have written some payment related logic and you may have written it into some tightly coupled way, right? And
Mm-hmm.
so that things needs to be sorted out before you go and make them into an independent service, right?
Okay.
That is how you should go and break your application into multiple microservices, right?
Awesome.
Uh, Also, there are people who also prefer. So once you have your monolith application, they break down before they transition into microservice. They break down into multiple modules, right?
Yeah.
And you may call it modulate application. You are like
Mm-hmm.
setting the stage for your application to be converted into microservice somewhere in the future, right? So
Yeah, I
you
think I
break them
prefer
into
that
multiple,
better.
yeah. So you convert them into multiple modules, and those modules, they in some sort of other way, they stay independent with each other, and
Mm.
then slowly and slowly, you convert them into a microservice architecture. And once you break down all the services into microservice architecture, then there are some other types of other components which you also need to put into your microservice, like
Mm.
because you have independent services, so those independent services needs to be registered somewhere, so you also need to add like service discovery in place, right?
Mm-hmm.
You also need to have a separate API gateway into your application, right, which will be acting as the front gate of your application, where each and every request to your architecture will be going through that gateway. There also has to be some authentication, centralized authentication mechanism needs to be in place whenever you are like dealing with microservice architecture. And there are like tons of other types of considerations you need to make, like in your monolith application you must be also having your common database, right? And
Mm.
you also break your database into you know small databases for each service, right? There are people who prefer single database as well, but that is not good in terms of scaling. So each
Mm.
service have their own database. That is one of the good, at least the kind of best practice I have seen in the projects I have worked on. So you also break your
Yes.
database into multiple, based on your those services, they will have their own database, so that whenever you want to scale your product service, you are easily you can do that, right? If it has its own separate database, it will, when you also have a separate database, right? So you won't face any sorts of issues like deadlocks or something, right? It won't block the entire database.
Yeah.
Even if there is a problem, only that one single service and database may be affected, and your other features will keep working without any issue.
Awesome. Yeah, so you've basically given us the steps on how to introduce microservices into our monolith application. And I'm just going to recap what you said actually, because you've actually given us all the steps. So I think the first thing is to assess the problem, right? So if you are called to transition a monolith application into a microservices, the first thing is to assess the current monolith application and identify the bottlenecks, like the problems surrounding the pattern that is used, and then also try to understand the domain, right? So, what is the domain of the product? Is it e commerce? What is it? And when you've done that, try to break down each modules, like you mentioned, in terms of the modular monolith approach, and then try to also map these dependencies, right? So try understand how different modules and components are kind of dependent on each other. Okay, so this is all about understanding the current monolith application and how it was built, and then you start your breakdowns, right? And then another thing is to introduce or define the strategy pattern for migration. And I believe we have a lot of patterns for that. So we have the strangler feed pattern, and then we have the DDD, which is domain driven design pattern. So depending on the one that you prefer to use, I personally prefer the domain driven pattern because it helps me kind of understand the business domain, and then I can easily identify the bounded context that is related with these different business domains. Right. So after I have identified the pattern I want to use, the next thing is to identify the business domains and the bounded context. Right. So that simply means that if it is e-commerce platform, I understand that there would be ordering process or processing, there will be payments, there will be user management or user service, right? So I can easily just pick these things out and start building them independently. And after this, I will try to use inter-service communication to communicate within these different services. So I prefer gRPC in this case, but a lot of people prefer Kafka and RabbitMQ and all these different things that makes it easier. Okay, so I prefer the resource-based inter-service communication. All right, but anyways, anyone you decide to use. So once you are able to communicate within these different services, then you have a microservice because that is what it is. So you have this service, you have this other service, and you have a better communication between them, right? And when a user accesses a particular service, and then you are able to serve that service to that user, basically you have a microservice. Okay, so other things that comes in place is all about security, how do you deploy individual services and all of that. Thank you very much for sharing that. And I just broke down what you said because I'm also learning.
Yep.
All right, so we have the next question. So the next question says, how to build a secured microservice. Now, we have a microservice now. You just told us how to transition from a monolith application to a microservice. How do we secure what we've just built, right? Because without security, microservice won't be useful because we can't be transitioning from a system that is secure to a system that is not secure, right? So how do we build a secured microservice?
Right. So security is a very broad term, right? Security can be
Mm-hmm.
also at the physical layer and also at the software layer, right? Security can also be at the cloud layer and also at our application layer as well, right? So security is a very sort of broad term. I'll explain security more in terms of your application level security, right?
Yeah,
So
yes.
first of all, there's microservices, right? So since you have, so why you need to like care more about security in terms of microservices, because earlier you only have one application monolith. Now you have converted into 15, 20 microservices, right? So now you need to care about all those small services, right? So that's why security is very important. So what you do normally one of the practices which I've seen is that people they use a centralized authentication server, right, which is responsible for doing the authentication of your users, right? And that is your central place where you do the authentication, right? So sometimes it is plugged with the API gateway, right? So API gateway is the
Mm.
first service, right, which you need to maintain, which acts as a front gate to your application, right, where each and every request to your coming to your application will be redirected, right, will be actually
Yes.
passed through that API gateway, right? So nobody from the front end will directly going to call your service, right? So first you need to put a API gateway in place, which will basically filter out all the authorized request versus unauthorized request, right? So let's say if there is some unauthorized request came, so API gateway normally redirects it to the authentication server, right? That authentication server will basically throw some maybe 401 error, right? If the user is not authenticated, then the user will the front end will basically go and authenticate your with your backend, right?
Yes.
So using the authentication server endpoints, right, it will basically authenticate, and in return it will get some JWT token something, right? So
Awesome.
using that token, then it will again call your API gateway, right? So now your request is authenticated. Now your API gateway will let it pass through your services, right? Which is your downstream microservices, right? So let's say now your request went through inside your services, right? Now between service to service communication also, you need to make sure that you are actually serving any authenticated request only, right? So within your services also, you will go and check that token, whether the token is valid or not, right? So your request will basically carry that token, and based on that token, your authentication, your each service will also make sure that your user is authenticated or not, right? Apart from
Mm-hmm.
authentication, there is also another layer, which is the authorization part. So you need to also know, like, if your user is allowed to access the payment page or not, or is
Mm-hmm.
your user allowed to make the payment or not, right? So there can be a lot of
Mm-hmm.
privileges, whether your user is assigned those privileges or not, right? You also need to make sure, apart from authentication, right? So your services, right? So normally what you do, either you make a single service which is responsible for doing both authentication and authorization, or you can also keep them into separate services, right? I have worked into applications where we are maintaining these two things separately. In one service we do
Mm-hmm.
the authentication, and in one service we do the authorization, right? So authorization basically takes care, it's basically a register where it is mentioned that this user has access to this privilege or not, right? So that is the service to service kind of, security you need to put in, right, by validating the token and the rights, whether that particular user has rights or not. So these are, like, the basic kind of authentication, right? And the ways to make your services more secure, right? And there can be other things as well, other kinds of considerations as well. You need to, you can make sure, right? Like, let's say if you are exposing your APIs, right, to some third party vendor, right? And so you may also need to, like, think about authentication and authorization in that case. And there are some, some good sorts of principles which you can also keep in mind while designing
Mm-hmm.
the security of your application. There are some, best practices, right, which you need to keep in mind while designing your, so basically you need to, like, think about security in terms of, you first of all, you need to protect your, your cloud infrastructure where you are actually hosting your service, right? And
Mm-hmm.
then inside your application, you need to take care of security mostly yourself. So as a backend engineer, mostly the cloud part will be maybe taken care by some DevOps engineer, maybe working in your team. Your responsibility as a backend engineer is mostly related to the application level security, which you are basically responsible for.
Awesome. So this is quite broad. You've mentioned a whole lot of things around securing your microservices. Now, you mentioned something very important. You mentioned secured communication. This simply means that you talk about securing individual services, right? So if service A is talking to service B, there should be a layer of security between each. Okay, so I believe they can use something like TLS or HTTPS for that communication, all right, to make that communication secured. And you mentioned that, which is awesome. And then you also mentioned securing the endpoints, that's the API endpoints. Of course, as a backend engineer, if you are building endpoints, you should make sure that it's secure, either by making sure that only people that are authenticated have access to that endpoint, or lots of different layers of security, as we know as backend engineers in terms of securing endpoints. And then next, you mentioned least privilege. Now, this ensures that a service. This is very important. You actually mentioned this. So this is this is making sure that a service only talks to a service that it needs, right? So if service A does not have anything relating to service D, then there should not be any form of communication between them, right? So services should only have access to services that they need to communicate to, and that makes it very secure, because if somebody has access to service A and their end product is to gain access to service D, that would not be possible, because service D do not have access to service A do not have access to service D. All right. And then you also mentioned, of course, encrypted data. This is important. When you are sending data, it should be encrypted. But most importantly, you mentioned infrastructure security, which simply meaning that your cloud system or cloud provider should be secure enough to guide your application. And this is beyond the scope of backend engineers. This is for the DevOps guys to make sure that the cloud providers are secured. Okay, and another thing that I could add is make sure that you always log your system and monitor them using all these different logging and monitoring systems that we have. To make sure that you identify bottlenecks and problems as your users interact with your system. Okay, and then also do software testing, API versioning, and secrets management. So this could also help in terms of securing your microservices. Thank you very much, Vikas, for sharing this. And of course, we have another question, which I'm going to ask you. So it is how to scale microservices. Okay, so now that we've created our microservices, we have actually learned how to secure them. Now, the main reason why we ran away from Monolith was because of one was scalability. So, how do we actually scale microservices? Since we have different services, what is the best pattern to scale a microservice? Right.
Correct. So, so when developing your microservice, right? So first of all, the thing which you need to keep in mind is that your microservice is using single responsibility principle, right? That means that one service is only responsible for doing that one thing. Okay. So
Mm-hmm.
now, so that the scaling becomes easy in that case, right? Because if your microservice is doing multiple things, then and out of those multiple things, if you only want to scale that one thing, then scaling it will be
Mm-hmm.
difficult, right? So that's why first of all make sure that it follows that. Next
Mm-hmm.
thing is that your microservice, let's say you have your microservice, okay, so your microservice should also need to have its own separate database, okay, so
Okay.
that your scaling will be easy. Now there are like couple of things which we do normally. There can be a lot of other ways to scale your application, but normally what we follow is that we use the containerization. Okay, so we
Mm-hmm.
convert our application into Docker images, some lightweight Docker image, and
Yeah.
scaling your Docker image becomes very easy. You use some container orchestration tool like Kubernetes, one of the popular one. So we leverage Docker plus Kubernetes, and that's why the scaling becomes very easy using Kubernetes, right? So
Mm-hmm.
Kubernetes basically it gives multiple ways to scale your application. You can scale your application in both the ways: horizontal scaling, and you can also do
Yeah.
vertical scaling, right? So let's say your application is mostly uh, if your application is if not doing any sort of CPU intensive work, right? Then what you can do is you can increase the number of nodes your application is running into, right?
Okay.
If right, so that kind of scaling you can do, that is horizontal scaling for you, right? So try to prefer horizontal scaling. Okay, that is one of the good things, because in that case your application is very light in nature, and scaling it to multiple replicas, right, becomes very easy, right? But
Yeah.
there can be few cases where your application is doing some CPU intensive work or IO intensive work, right? In that case
Mm-hmm.
you may need to also consider about some vertical scaling part, where you go and increase the resources of your application, like increasing RAM or memory, or CPU. So these are like two sorts of techniques which has, and using it with Kubernetes makes your life very easy as a backend engineer.
Yeah.
And so you can also use automated way of doing it, but
Mm-hmm.
automation you will be able to perfect automation over time, right? At the first go you may not be able to perfect the automation, because by automation what I mean is that Kubernetes comes with HPA, or horizontal part auto scaling. So based
Mm-hmm.
on some triggers it basically you know scales your application, right? It increases the nodes of your application, right? So
Mm-hmm.
if you are not sure what you are doing, just go and find some pretty sweet spot of the numbers which based on the load, that this is the number of resources and the number of nodes you need to your application, and just do it like that. Or if you know what you are doing, right, if you have worked to your application over time, and now you have matured and so now you can go and take some decision of doing some auto scaling into your application where you can uh, you know go for horizontal scaling, and you can write some triggers, and based on those triggers your application can be auto scaled.
Awesome. So you've made it very clear, and I really like the points that you listed out. First, you talked about horizontal scaling, which is like the primary scaling pattern for microservices, right? And then you also mentioned auto scaling, which is great because I think Kubernetes can also help a lot in this case. You just write some triggers, like you've mentioned, and then it does the auto scaling for you. Okay, so another one that you can use is data scaling, where you try to look at your database and then you look at different ways that you can scale your databases, right? And then we have sharding, we have replicas, all these different patterns really works when it comes to scaling your database. So thank you very much for mentioning horizontal scaling and auto scaling. This is really great. So we have another question. So this one, I want you to list and kind of explain some of the design patterns in microservices. Okay, so we have things like circuit breaker, CQRS, Saga patterns, and there are lots. So I want you to kind of throw, insight into these different patterns and when to use them.
Yeah. So all these patterns, they come in picture when you have they are good for solving some uh, specific type of problem, right? Let's say when you have a requirement of scaling your database, right? As you mentioned
Mm-hmm.
that on the database side also you need to think of scaling, right? Then one of the best ways to do this is using by following this CQRS principle. So CQ in the CQRS principle, so CQRS does not allow you to scale, but before you go and scale, you make sure that you are using the CQRS principle. So where what you need to do is you separate out two types of operations in your application. One is that
Mm-hmm.
your all your read access, right, or your read operations, right, into your data,
Mm-hmm.
with whether that should talk to your read only instance of your database, right?
Mm-hmm.
And the other type of operation is the write operation, right? Whether you are deleting,
Yeah.
updating, or creating a data, that can be considered a write operation. That may be talking to a write only instance, right? I mean, read write instance of a database, right? So
Mm-hmm.
using this CQRS principle, you basically separate out these two concerns, right? And your separate instances, they manage the communication in these two ways, right? So what happens is whenever you want to scale something, that is only requiring the read operation, right? Then you can
Mm-hmm.
go and scale your application in that way. You can scale your read or read only instances, right? And that's how with using the CQRS, you basically separate out these two operations and you connect to their respective instances, right?
Mm-hmm.
That is your CQRS. Another pattern which you
Awesome.
mentioned, yeah. Another pattern which you mentioned is the Saga pattern. So let's say if you are facing some issue in regards with the distributed transaction, right? And you want to manage your transaction on a distributed application, right? So microservice is by nature a distributed application, and it has their own databases, right? And if you're making some sort of transaction which is involving multiple databases, right, then
Mm-hmm.
you can go with the Saga pattern. So Saga pattern will basically help you uh, you know manage your transaction in a very nice and smooth way, where what you do is with every, so let's say you are doing user registration, right? And that user
Mm-hmm.
registration is involving three steps in between, and in the
Mm-hmm.
last step you actually need to go and register the user, right? So and since this all these steps are talking to multiple databases, right, in between, right? So what you can do is you can utilize this Saga pattern. So Saga pattern, what it will do, and let's say if any of this step fails, then Saga, using the Saga pattern, you can basically roll back all your changes to your database. So at every checkpoint, you also mention the compensating action, right, which is responsible for reverting back whatever changes you have done in the database, right? So that's where the Saga pattern comes into picture, right, to manage this distributed transaction. And what else you mentioned?
Yeah, I mentioned the circuit breaker pattern.
Yeah. Okay. So let's say that your application is experiencing some slowness, right? Then what you can do is you can put the circuit breaker pattern in between. So what circuit breaker pattern will do, so let's say you have service 1 and service 2, okay, and service 1 is communicating to service 2, okay, and service 2 is slow, so that will make service 1 also slow, right? So in this case, what will happen is you put circuit breaker in between. So what circuit breaker will do, if this service is slow, so you define some configuration in circuit breaker, right? So you define some duration, that after this duration, if service is not responding, you consider that as a slow service, right? And based on that slowness behavior, you put the circuit breaker pattern in between, right? So if this service is slow, so this service will get some dummy response, right? And that response could be anything, right? Whether it could be some sort of status showing that this service is not doing good, or it may be some other sorts of things you can implement into that circuit breaker pattern. So your service one, if the service is slow, it will basically with that circuit breaker pattern, the circuit breaker pattern will send response to this service, and then this service can return the request, right? So that your service, this service one is not getting affected to this service, because this service may be communicating to service 3, service 4, service 5, right? So only that particular operation which is involving that service 2 which is slow, only that operation gets affected, right? Otherwise, if you don't put circuit breaker in between, it will make your entire service 1 slow, right? And that may cause an issue, right? So that's why in order to deal with such type of issue, right, you use the circuit breaker pattern.
Yeah, thank you very much for giving us a deep dive into these different patterns. There are lots of other patterns that microservice engineers actually use, but you've cleared the level on these ones, and thank you very much for your inputs. Okay, so we have the next question, which is very, very important. Now, this question is when not to use microservice, right? So we understand that microservice is this one giant good pattern that we can use for our products. Of course, when we are ready to scale. But even at that, there are some systems or there are some situations that may not need us to use microservice, right? So I want you to explain to us when not to use microservice.
Right. See, the simple answer is if your application is small, right, and you may not have that much user, no make does not make sense to use microservice and bear those infrastructure costs, right? That is one of the
Yes.
considerations. Another consideration is that so microservice has some operational cost, right? Operational infrastructure cost. So there will be some level of minimum cost attached to it. So if you don't need that scalability, right, or that your application is not that complex or not that big, right, then going towards microservice architecture may not make sense, right? So that will be a very simplified answer to this question. And over the
Of
period
course.
of time, right, when you realize that your application is growing, adding up complexity, and there is some need to break down your services, then there you can take that decision of choosing that architecture.
Mm. Yes. So you actually summed that up. one thing that you mentioned is when your application is small, you don't really need a microservice because at that time it will be over engineering and then introducing unnecessary complexity when your application is small and you want to start off with microservice. You also mentioned something very important. When you can't afford the high cost or the high operational cost, you shouldn't think of using microservice because there will be high cost in terms of infrastructure, and then there will be high cost in terms of the operational complexity. Managing and debugging issues across multiple services will require engineers. Example, if you're using different programming languages for different services, you would need engineers that can do the job on these different services. Okay. And another thing I like to add is when you need rapid prototyping. So if you're just building your MVP or you are doing prototyping, you don't really need to start with microservices in that case because that would definitely just introduce slower development and it will delay your time to market. All right. Okay, so thank you very much for your time and giving us this insight into microservices. I think I have one last question, but I will just ask you, but this is not very important. So the last question is, logging and monitoring in microservices, right? So how do we introduce logging and monitoring into microservices? Now, this question is coming from the angle where we have different services. How do we monitor all these services, right? And is there like a product or tools that can be used to monitor all the services, like a central monitoring system? Okay.
Yeah. So monitoring and observing the monolith application is very easy because you have only one component, right? And you can use any kind of logging framework and you can do it, right? But microservices are basically distributed in nature, right? So if we take an example of an architecture where we have 20 different microservices, right? Then whenever there's some issue came, you cannot go into each and every microservice and you can check like what is wrong, right? Because your one API may be calling 5 different microservices, right? And as an
Mm-hmm.
engineer, you may not know at what layer it is breaking, right? So
Mm-hmm.
that's why this logging, centralized logging becomes very easy for, very important for you, right? So there are some
Mm-hmm.
tools which are very popular in doing this. One of this tech stack is ELK tech stack, where you use Elasticsearch, Logstash, and Kibana to
Mm-hmm.
basically centralize your logging. Okay, so Elasticsearch, where your logs are stored and indexed, right? So you can go and search, right, using Elasticsearch. So Kibana basically a UI using which you go and check which microservice is printing which log and where the issue could be, right? And Logstash is basically to capture the logs, right? So ELK is one of the popular tech stack, and there is also one nice product that comes, which is Datadog, and so I have used Datadog to uh, capture the logs and put this logs into a centralized place, right, where you get lots of features. You can trace some given metrics. You can set some alerts based on your logs, right? You can do a whole lot of things, right, using Datadog. So it's bit of an expensive product, but in my previous project, right, where I have worked, it was a banking project, so they can afford it, right? So they have used it. So that is also one of the options, right? You can go for, right? So these two are basically tools and things I'm aware of. While there can be others as well, right? But I have seen ELK is one of the most popular ones which people normally use.
Awesome. Yeah, so it seems to me that we've discussed everything around microservices, but of course, I know there are lots of things to talk about. But this was very insightful, from learning what microservices are to, discussing logging and monitoring in microservices. Do you think that there are, other things that you might want to talk about or might want to add in microservices that we did not cover?
I think for a somebody who is a beginner and who is like learning what is microservice, this much information is enough. But there
Mm.
are some good sites you can go to, like microservices.io. You can go to those that website, and it covers a lot of resources on microservice. So you can, if you want to go into deep dive into microservice, then that is one of the resources I will recommend people to go to. And microservice
Mm.
is having its own complexity, right? So we can have a separate section, a podcast on each separate section of microservice. Like if you want to discuss security, we can have a separate podcast on this. If you want to talk about
Mm.
observability logging, you can have a separate, so if you want to like scale, so it's a very very broad topic, right? And I'm
Mm.
happy to do a future podcast, or if you want to deep dive into some specific portion of the microservice, right? We can do that. For now, I think this should be enough for our viewers.
Definitely, we are going to do that. In fact, I'm going to set my calendar for some other topics. I think the first one is, now we have a theoretical, aspect of microservices. This is like the introduction to it. One thing I would love is one simple practical of microservices where you and I, we build a simple microservice. Like maybe you build with Java, I'm going to build with Node.js on live like this, and then we connect it together and it works. And then from there we have that practical out there, and then next we can start talking about these different aspects or topics of microservices and how we can integrate them into what we've just built. Okay, so it's going to be like a series like that. Okay, so I think we can do that.
Yeah, sure,
Right?
sure. Definitely, we
All
can
right.
plan that.
All right. So thank you very much once again for joining. This was very, very insightful. I actually got to learn a lot. Like I think the way I do microservice is different from the way you do microservice, and your knowledge is really, really nice. I like it, and we are going to do this a lot more. Okay. So thank you very much for tuning in, and guys, thank you for staying to the end. This is the end for this episode of this podcast. Now, you can reach Vika on different social media platforms. I'm going to allow him to share his platform and some of the places that you can contact him. But of course, you can always contact me on Twitter at Kapasky Guru, and then LinkedIn at Solomon SMA, and you can join my newsletter at backendweekly.dev. So, Vika, can you share where our listeners can contact you from?
So I'm basically active on Twitter, and I'm active on LinkedIn as well. I'm also building up my own website from the scratch, so it will be live in few months. So my Twitter ID is at the rate Vikas Rajpu in. Okay, I'll ping you the IDs, and you can maybe add up into the description of the podcast so that viewers can go and find
Sure.
my IDs. Yeah.
All right. So please follow Vika. He is good at breaking down complex microservice topics. I've been following him for years and I've learned a lot. And with this, we've come to the end of the podcast. Thank you very much for tuning in.
Thank you. Thank you so much for having me.